let's go through these different constraints. So for the first one, they cannot buy more than 144 caps. Am I writing an equation or an inequality here? Inequality. It says they cannot buy more than 144 caps. Which variable should I use here? C. So I know I need the C. I know I need 144. Would I use a less than or a greater than here? Less than. Says they can't buy more than this. It has to be less than. Could we have the or equal to underneath this? Yes. C is less than or equal to 144 caps. For the second bullet point, they must buy at least 200 bumper stickers. Is this an equation or an inequality? Inequality again. It says they must buy at least 200 bumper stickers. Which variable or variables do I need here? I just need B. That's okay. Greater than or less than here? Greater than. Can I use the or equal to? Yes. B is greater than or equal to how much? 200. All right. 2 down, 3 to go. Third bullet point, they want to sell a combined total of 400 items. Equation or inequality? Equation. It's telling me what they want the total to be, not less than something or greater than something, not more than or at least, not at most. I know what I want this to be equal to. If I have a combined total, how do we combine things in math? We add. What am I adding together here? C plus B equals what? Equals 400. Beautiful. All right, next one down. The total cost when caps cost $2 each and bumper stickers cost 75 cents each. Equation or inequality? Equation. Do I know what the total is?
No, it's not. It's
2 each. 2 each for what? Ibrahim, I'm going to chase what you said for a minute, and then I'll come back to the total.
We don't know what the total is.
We don't know what the total is.
We gotta do 2 times C and then 2.
That's what I was about to say.
Here we go.
5 times.
I literally just said that. I said $2.
You did say $2 each, and I had just asked you each what, and then we hadn't gotten there.
Exactly. So
Okay.
so
Do we know the total dollar amount that they want to make?
no.
No. So I'm going to have to let a variable represent this, or I could use function notation. Are you guys okay if I use a capital T for total? All right, so capital T is equal to, how are they going to get up to this grand total?
C times 2.
C times 2, so 2C plus, because we're going to put that together. 2C is all the money that we're making from caps, right? $2 for each, so if I took $2 times the number of caps, that'd be all the money from the caps, plus what? 0.75 B. What does the 0.75 B represent? Just this right here.
The bumper cost per bumper sticker.
That's the bumper stick. That's the cost per bumper sticker. But then I'm multiplying it by B. So what would doing this multiplication tell me?
How many they sold?
How many they sold would be B. 0.75 times B, that would be the total cost that they would have to pay for all the bumper stickers that they order. All right, last one. Are we talking about the cost to them? Because the one up above, this is what they're going to have to pay their suppliers. They don't create bumper stickers. They're going to order these. They don't create the caps. They're going to order those. And then they're going to resell them to other people. In that very last one, are we talking about how much they're going to have to pay their suppliers here? What is this last bullet point telling me?
They earn $5 of revenue for each cap.
What's revenue?
The amount of money
The amount of money what?
they made from
The amount of money that they make, yes. Their revenue, that's how much they're taking in. Technically, profit is how much they make, but revenue is how much they're collecting from people. Do we know what their revenue was? We know their total revenue?
Oh, no.
No. So if I don't know it, what do I represent it with?
R.
I need some kind of a variable. Let's go with an R for revenue. How do they get the money that they're collecting? What are the pieces that are going to make this up?
5 times C.
5 times C, because we have for each cap, so 5C
Plus 2B.
plus 2B. Why is it plus and not minus?
Because percent total for each.
How would I know on a problem like this when I'm supposed to use a plus versus a minus? How would I know on a problem like this whether to use a plus versus a minus? They're adding $2 for each bumper sticker. And what else? $5 for each cap. What we're looking at here, guys, it's really important that you're understanding the language that's going on so you know whether we're adding or subtracting things. Total revenue is the collection of all the places that they're getting money from. So they're getting money from caps, and they're going to put that together with the money that they're getting from bumper stickers. All the money would go into one big cash box, so we'd be adding those pieces together. If we were wanting to find out, like, okay, so what's our revenue? We've got this total, we've got that total, but then they're like, oh, I actually had to go buy a tablecloth with a banner on it so that people would know where to come and get this. That would be an expense, so that would take away from my revenue because I would have to give that money out of the cash box. Make sure, if you don't understand what the vocabulary means in these story problems, make sure you're asking. I'm happy to tell you what these terms mean. From there, you would need to decide what to do with it to write your equations, to solve your equations. But if you don't know the vocabulary, please ask. All right. In your books, we're going to be on page 86. Yes, sir.
Can I jump to my page because she's about to leave. She doesn't use this.
Yes. All right. Yesterday, we talked about solving absolute value equations. What does absolute value mean again? How far away we are from zero. It is a distance away from zero. So absolute value is always what type of number? Positive number. Today we're going to talk about inequalities. When we did our equations, we got how many answers each time? When we were solving the equations yesterday with absolute value, how many answers did we get each time? 2. Because when I'm talking about distance away from zero, I could be that far away on the right in a positive value, or I could be where? That far away on the left in the negative values. So I've got 2 locations that I could be at and be that distance away from zero. Inequalities. There's a couple things that we have to talk about, and I'll warn you guys right now, I don't like the way your book does some of this, so we're going to do some writing in the margins, and we're going to scratch out some of the ways that they do it. I want to look at this one first. I'm on page 86, and we're definitely going to need to write in the margin off to the side from this key concept box here. What symbol is this? Is that a less than or a greater than?
Greater. I mean, less than.
Less than.
I need my glasses, bro. No, she said some of it is not.
But we're not there yet. Right now I'm just referring to what's printed.
All right, yeah, it's a less than.
Okay. That is a less than. What does absolute value mean again? What does absolute value mean again?
A number is distance from zero.
Distance from zero. All right. So I'm reinterpreting these things into English so that I can make sense of them. This says the distance is less than whatever this number C is. I'm just letting C stand in for a number. C units from 0. The distance is less than C units from 0. I'm going to talk about this a little bit with some numbers, and I want you to help me reason through it, and then we're going to draw a picture to help us understand this better. If I'm exactly 5 miles away from Pike High School, think about this on a number line. I could be 5 miles this direction, or I could be 5 miles on the left side.
Or straight.
I'm thinking about it right now just like on a number line.
All right.
We're going to try to keep it simple.
All right, my bad.
So I'm either at +5 or -5, right? Where could I possibly be if I said I am less than 5 miles away from Pike High School?
0.
I could be right at 0. I could also be
At 10.
-10. If I am less than 10 miles or less than 5 miles away from Pike High School?
Oh, never mind. It would be like 1, 2, 3.
1, 2, 3, 4, all the way up to 5. Not more than 5. What about on the other side? Where could I be?
Less.
Where could I be on the other side if I'm less than 5 miles away?
Oh, -1, 2.
-1, -2, -3, all the way to -5, but not past there. I want to draw a quick sketch of what that looks like. This is where you'll probably need to be in the margin. All right, so absolute value of AX plus B is less than C. On my number line, if 0 is here, I could either be on the left or the right. Those are the edges of my boundaries. Farthest to the left, farthest to the right. If I am less than C units away from 0, I could be anywhere in this space that is all less than or smaller than C units away, right? This distance right here, do you guys agree that that is closer or less than? Yes. On the other side, I still want to be really close to 0. If I am less than C units away from 0, it's going to be shaded in between those two boundaries. Those represent all the distances that I could be if my distance is less than. All my possible locations. So again, I'm going to write up above here exactly what we just said. The distance is less than C units from 0. Guys, focus on math right now. What questions do we have before I talk about the other inequality? What questions do we have? No questions? Okay. This one down here, bottom box, is that still a less than here? That is now a what? Greater than. What does greater than mean? Give me another way of saying greater than. Greater than means more or less? More. So bigger. If I'm talking about distances that are bigger, that means farther away, right? Distances that are more than, that are greater than, are farther away on the number line. So this inequality down here says my distance is greater than C units from 0. My distance is greater than or more than, bigger than, farther than If I tell you I am more than 5 miles away from the high school right now, could I be 1 mile away? 3 miles away? 20 miles away?
Yeah.
Yes. If I'm thinking about a number line where my positives are off to the right and my negatives are off to the left, could I be at negative 35 and be more than 5 units away?
Yeah.
Yeah.
No.
Wait,
Yeah.
say it again.
Yeah.
If I'm thinking about a number line, let me draw this real quick. Here's 0, so here's the high school. I've got my positives over here. I've got my negatives over here. Is this more than C units away from 0? What about this? This? What about a number right here? Is this more than C units away from 0? No. So all the things over here are more than C units away from 0. Where else could I be and be more than C units away from 0? Sir.
I'm guessing if it's the same either way, anything past the positive C would still.
So when you say past, does that mean I should shade more this way?
I mean, other way.
Other direction. All right. This is AX plus B is greater than C. My distance is more than C units away from 0. All right. Something I want to point out before we try a problem. When my absolute value is isolated, first of all, when I see the absolute value and it's isolated, I just read this as distance. My distance is less than. I'm heading towards 0. It's going to be shaded in between the positive and the negative boundary. Down here where my distance is greater than, and I'm heading in opposite directions, if I'm heading off to the right like this, would I use a greater than or a less than here? Greater than. What about over here though? I'm here or getting farther to the left. When I keep moving to the left, would I use a greater than or a less than there? I would use a less than. So when I have an inequality like this, where it's less than, it's shaded in between, my absolute value is less than. Sorry, I should have clarified that. I'm going to have negative C and positive C that are my boundaries for this piece on the inside. I end up writing what is called a compound inequality. This part that's shaded is what's being represented by this. I have my lower boundary and my upper boundary, and we've got it shaded in between. So I put that value in between those two. When I have a greater than, I have isolated my absolute value, and I have a greater than. My inequalities have to be split up because they're going opposite directions. Inequalities get split up into 2 separate pieces. This one, again, what's shaded is represented by what's on the inside, and it is moving this way. This is all bigger than C. But over here, if I'm moving to the left, you said I use which kind of a symbol? Less than. Negative C. I have to write these as 2 separate inequalities. It's going to be greater than the positive or less than the negative. That's how my distance gets farther away from 0. In your book, I don't like the way it does the less thans. Those are the ones that we are going to rewrite. And we'll find room in the margins to do that. Let's go look at example number 5, still on page 86. Do you guys remember our 4 steps from yesterday to solve an absolute value equation? What was our first step? Isolate. Then we had to split it into 2 cases. We're still going to do that here, but the way I get my cases, I need to know whether it's going to be shaded together or opposite directions. Then we will solve. And our last step on this is we will graph. Yesterday we had to check. Today when I get my inequalities, we are going to graph this. So far so good? All right. Is my absolute value isolated on one side in this equation here? Is my absolute value isolated on one side? No. Here's my absolute value. This is the part that means distance. I need to isolate this. So I'm looking just on this side. Remember, I can't touch anything in here that I'm trying to isolate. What's going to have to go away then?
Add 5 to the negative.
Yep, we're going to add 5 to both sides. So over on the left, I have absolute value of 4x minus 8. I have a less than. What's 11 plus 5? 16. So far, so good? All right. Think about this with me. Absolute value means what again? Distance from 0. Absolute value is distance from 0. So this side means distance. Which inequality do we have right here? Less than. The distance is less than what? Nope, I'm reading this straight across. Absolute value means distance. Distance is less than, what's on the other side? What is this piece right here? 16 units from 0. If 0 is right here, what are my lower and upper boundaries here? What's my lower boundary? What's my upper boundary? If I say my distance is less than 16 units from 0, what are my 2 boundaries? I'm looking for a number here. What's my lower boundary? Close. Negative 16. What's my upper boundary? 16. If I say I am less than 16 units from 0, where could I be? Yes. In between the negative 16 and the positive 16. This is where I could be. For the equation part, this is the part where I don't like the way your book has done this. Find a spot. This is how we are going to write this now. I'm going to take what's inside the absolute value, 4x
I got a question.
minus 8. Yes.
So with the less than 16, why would it be in the middle?
Why would what be in the middle?
Like when it was positive 16, I thought it would be like, since it was less than 8, it's to the left.
Well, I am to the left of positive 16 because that, so what I have shaded here,
So if it was a negative, it would be to the left.
what in the world? Amber alert. Okay. Shh. What I have circled in red right there, that is less than 16 units from 0, right? On the positive side, that's closer to 0 than 16 units. Over here, I'm on the negative side of 0, but that is still less than 16 hops away. Does that make sense? That's what we're expressing right now. So 4x minus 8 is in between these two boundaries, negative 16 and positive 16. We are in between these two. Negative 16 is my lower boundary. Positive 16 is my upper boundary. Your book doesn't have a statement like this. Please write this in one of the margins and we're going to solve this. Your book splits it into two separate inequalities, and I don't like that way of doing it. It makes it way more confusing than it needs to be. My goal is to get the x all by itself. I have two different sides now where I have to watch out and do things on all sides. What do I need to do to get the x alone here? What would my first step be? I want to get the x all alone. What's my first step? Cancel the 8. How do I cancel the 8? Yes, we're going to add 8. I have two inequalities here, so I need to do it to both sides of this inequality. That's going to cancel. What is negative 16 plus 8? Negative 8. Bring my inequality down. I still have 4x in the middle. What is 16 plus 8? 24. What else do I need to do to get x all alone? 4. How do I get rid of the 4? What operation is sticking the 4 and the x together?
You gotta divide 4.
Yes, these are being multiplied, so we're going to use division to undo that. What is negative 8 divided by 4?
Negative 8 divided by 4.
Mm-hmm.
Negative 2.
Negative 2. What is 24 divided by 4? 6. Right. So this tells me that all the values that would work here are in between negative 2 and 6. Look at just this part. Ignore that 6 for a minute. Which one's bigger, the x or the negative 2? X is the bigger thing. So x is bigger than negative 2. What about over here? Ignore this part for a little bit. Which one's bigger, the x or the 6? 6 is bigger. So x is bigger than negative 2, and it is smaller than 6. Less than 6, bigger than negative 2. I do not like the way your book writes the solution. We're going to write interval notation for this, but I want to graph what it looks like first, and then we're going to practice writing interval notation. We did that for domain and range already. What should my number line look like for this answer? Where should I have dots? Here's my inequality. What are the numbers that I can put dots at? Negative 2. Open or filled in? How do I decide? Should I fill it in? How do I decide whether I should leave it as an open dot or a filled in dot? If it has the or equal to, does this one have the or equal to? No, then I leave it as an open dot on my number line. Where else can I put a dot? at 6. Do I want this one to be open or filled in? Open. How do we know? I'm looking over here. This one does not have an or equal to with it, so I do not fill that dot in. I want to make sure that I'm shading all the things that are bigger than -2, but at the same time, they are smaller than -6. So I'm going to shade in between these two values. And now we're going to write our interval notation. Interval notation can be used interchangeably with my inequality notation. Two different ways of representing where we've shaded this number line. What is the smallest value where we have any shading? -2. Did we have an open circle or a closed circle at -2? Open, so I use a parenthesis. So this is the farthest to the left. This is the smallest value where we have any shading. What's the biggest? 6. Were there any gaps in between -2 and 6 in my shading? Is there anywhere in between these two that it's not shaded? No. So this is my interval. This right here means the exact same thing as this right here. It's two different ways of writing the exact same idea. Both of these tell me that it's shaded in between -2 and 6. The parenthesis tells me that it's an open dot. That's the same thing the less than tells me. Over here, this parenthesis tells me that it's an open dot. Same thing this tells me. Let's go look at another example. Top of the next page, example number 6. Same 4 steps. We're going to isolate. We're going to look at our cases. We're going to solve and we're going to graph it. Where is my absolute value?
Isn't it 14?
This has an absolute value around it? Where's my absolute value? Up here on the top. This is the thing that I need to isolate. Right up here. Order of operations will always tell me what order I need to do things in. Guys, stick with me for the next couple examples, please. When I am isolating things, I have to start with which operations? When I want to isolate, I'm going backwards through the order of operations. Addition and subtraction. Remember, I can't touch anything that's inside here. Is there anything on this side that has a plus or a minus sign? Yes. How do I get rid of it? Subtract. What am I subtracting? I can't subtract 3. Remember, I can't touch any of the stuff that's inside my absolute value. Subtract 5. We're going to subtract 5 from both sides. What's 14 minus 5? 9. So I have absolute value of 6x plus 3 over 2 is greater than or equal to 9. Is my absolute value isolated yet? No. Remember, I can't touch any of the stuff that's on the inside. What's still over there that I want to get rid of? The 2. What operation is happening with the 2? It's being divided. So how do I cancel out division? Multiplication. We're going to multiply both sides by what's on the bottom of the fraction. We're going to multiply both sides by 2. So here it cancels. Absolute value of 6x plus 3 is greater than or equal to what? 18. Help me interpret this. What do these bars mean again? Absolute value. Absolute value means? Distance from 0. So this is telling me the distance is what? What's this symbol here? Greater than or equal to? Greater than. Give me another way to say greater than. More than. Bigger. The distance is bigger than what? 18. 18 units from 0. The distance is greater than, more than, bigger than 18 units from 0. All right, so I want to think about this for just a second because I want to make sure I get this set up right. If I'm 18 units away from 0, where could I be? I'm 18 units from 0 exactly. Where could I be? I could be at negative 18 or at positive 18. Let's pretend I'm over here at positive 18. Do I fill this in or not? Yeah. How do I know when I fill it in? Because it's got that or equal to. What about if I'm not at 18 units away from 0? I am greater than, more than, bigger than 18 units away from 0. Which way would I shade? To the right. What about if I'm over here at negative 18 and then I say, oh, I'm more than 18 units away from 0? To the left. If I want to get more than, farther away from 0, I need to run off this direction, right? If I'm running off to the left, what inequality would I use here if I keep going to the left forever and ever and ever? That's going to be a less than. Over here, it's a greater than. So greater than positive 18 or less than negative 18. The part that's shaded is what is represented by the piece inside my absolute value. So these are the two inequalities we're going to solve. Help me fill in these blanks from your book. Do I put the positive 18 or the negative 18 here? Positive. If it is greater than, farther away from the positive 18, I am getting farther away from 0. What about here? Negative 18. If I want to be more than 18 units away from 0, I'm going to be greater than the positive or less than the negative. On the negative side, both pieces are going to change, my symbol and my number. Let's solve both of these. What do I need to do here with the positive 18 if I want to get x all alone? Subtract 3 from both sides. Okay, what's 18 minus 3? 15. What do I do next to get x by itself? Divide both sides by 6. Do I need to flip my inequality when I do that? Why not? It's not a negative. You can pop this in your calculator and write it as a decimal, or we can write this as a fraction, but that's not fully reduced. I can think of a number that go into both the top and the bottom. What goes into both of those? 3 goes into both of those. I can divide the top and the bottom by 3. What do I get if I divide both the top and the bottom by 3? I get 5 over 2. So x is greater than 5 over 2, or I have to come over here and solve the other one to figure out the other possibility. What do I need to do over here if I'm going to get the x all by itself? Subtract the 3 again. What's negative 18 minus 3? Negative 21. And then what? Divide both sides by 6. If I do negative 21 divided by 6, do I get a whole number? No. I can reduce that fraction, though. You can always write it as a decimal if you would prefer. What goes into both 21 and 6? 3 again. What's negative 21 divided by 3? Negative 7. 6 divided by 3 is 2. So x is bigger than to the right of 5 over 2, or it is less than negative 7 over 2. Grab some calculators for me. I want to get some decimal approximations here. I think that's correct. Let me double check it. Give me just a moment. 5 over 2, 2.5. So x is greater than or equal to 2.5. Oops. What about negative 7 over 3? Or sorry, negative 7 over 2, my bad. Negative 3.5. Gentlemen, put it away for now. I want to go graph this. Over here on this number line. X is greater than 5 over 2. X is greater than, 2.5. Where does that go on my number line? Positive side. In between 2 and 3. Open or closed dot? Closed dot here. And then I want the things that are greater than, bigger than. Which way do I shade? To the right. Right, so that is x is greater than or equal to 5 over 2. X is greater than or equal to 2.5. Two ways of representing the same idea. Stick with me here. Jane.
Oh, sorry.
Thank you. Am I done graphing? Did I get everything I needed? Is this picture done? Does this show me all my possible solutions? I got to do the other one. Where do I put my other dot at? In between negative 3 and negative 4. And I shade the same way? No, that's going to get me closer to. I don't want to be closer. I want to be farther away, greater than. This way. That is x is less than or equal to negative 7 over 2, or x is less than or equal to negative 3.5. All right. So this is my inequality notation. Let's talk about how to write this as an interval. Interval notation. My interval notation should be describing where it is shaded at. Did I shade in one spot or two spots here? Two. So I'm going to need two different intervals. We're going to write the one on the left first. We always start on the left and move our way to the right. What is the farthest to the left this is ever going to be shaded? Negative 5 is where it stopped?
Infinity. Negative infinity.
Negative infinity. parenthesis around the negative infinity because I can't ever get to infinity. I couldn't put a closed dot on infinity. When did I stop shading as I move from the left to the right? Where did it stop? Negative 3.5. Filled in dot or open dot there? Filled in, so I use a bracket. What happens after negative 3.5? What happens right after that? Is it shaded here? We have to go all the way over to the other one, but I have to explain to whoever's reading my interval notation that there's this gap here. Do you guys remember what symbol I can use to indicate that there's a gap or a spot that's not shaded? A U. We're going to use a U for union. Where did we start shading again then? Where did we start shading? At 2.5. 2.5 had a closed dot on it, so I use a bracket. Where did I stop shading? Infinity. Nice work. There's my interval notation. All right. One more problem and we'll call it a day. Let's go look at a story problem. Next page, page 88. You with me, Ian? You can find out how much sleep you need by going to sleep without turning on an alarm. Once your sleep pattern has stabilized, record the amount of time you spend sleeping each night. What does it mean for a sleep pattern to stabilize?
To stay the same.
To stay the same, yes. Right now, if I go to sleep without an alarm, I sleep in really late.
You, like, personally?
Me personally. Monday through Friday, I don't get enough sleep. The alarm wakes me up really early in the morning. I'm not done sleeping yet when I have to get up. So on the weekends, I sleep in. But during the summer, when I don't have an alarm waking me up to come to school, my sleep pattern stabilizes. I fall asleep when my body wants to fall asleep. I wake up when my body wants to wake up. My sleep pattern stabilizes. The amount of time you sleep, plus or minus 15 minutes, is your sleep need. There's always a little bit of variation about how much sleep you get. If you don't have an alarm waking you up and you go to bed at about the same time each night, sometimes you wake up a little bit before, sometimes a little bit later, but it starts to be a pattern and you wake up around the same time each day. Suppose, pretend with me for a moment, that you sleep for 8.5 hours each night once your pattern has stabilized. We want to write and solve an inequality to represent your sleep need. And we're going to graph it on a number line. Yes, ma'am? Absolutely. Grab the pass. The difference, what does difference mean? Subtraction. The difference between your actual sleep need and the amount of time that you sleep is less than or equal to what? The difference between these two numbers is going to be what? 15. 15 minutes. The central value, the average, what did we say your average sleep need was each night? 8.5 hours is our central value, and 15 minutes is the acceptable range. 15 minutes is how much of an hour? A quarter of an hour. A quarter of an hour is what in decimal form? 0.25. So 1/4 of an hour or 0.25 of an hour. The difference between your actual sleep, we're going to let n be the actual sleep, and 8.5 hours is 1/4 of an hour. So n minus 8.5 is less than or equal to 0.25. So far, so good? All right. Let's solve this. Are you serious? Let's solve this guy. Which inequality is this again? Less than or equal to. Are they adding new report down there? Okay. Sorry, dear. Less than or equal to. If I think about a less than or equal to, you ladies can have a seat. I'm almost done. Less than or equal to 0.25. Where would this be shaded? If I am less than. Am I going away from, or are we shading in between? In between for a less than. I do not like the way your book does the less thans. So I'm going to come down here and change what we're doing here. In the margin, go ahead and write this in the margin. The part that's in between my absolute value, n minus 8.5, that is going to go in between my negative boundary and my positive boundary. What do I need to do to this now to get n all by itself? Add or subtract. Which one am I doing?
In this case, add.
What are we adding?
1.5.
Nope.
I mean, negative. I mean, positive 8.5. What you mean?
Which we're going to add 8.5 on either side of this. Yes. Yes, let me get that in there. You are correct. All right. What is negative 2.5 plus 8.5? Negative 2.5 plus 8.5.
No, I got it. 8.75.
Close. It's negative 0.25.
Negative 8.75.
Nope.
Whoa.
Negative
Oh,
0.25.
you talking about that's what I was looking over there.
As I pointed on the left. 8.25. Thank you, Elena.
Oh, how you get that?
If you spend a quarter and you have $8.50, how much do you have left?
8.25. Oh.
What about the other side? 0.25 plus 8.5. .25 plus 8.5. 8.75. Thank you. All right. Yep.
Is that one girl with the white hair your daughter?
Niece. Yep. All right. 8.25 and 8.75 are solutions. We're going to shade the interval in between 8.25 and 8.75. 8.25, 8.75. Everything in between these values would be an acceptable range for sleep. All right. You guys have homework due for me tomorrow. You have homework due for me tomorrow. These are the problems from your book. You are welcome to work on them now. They are due by the end of the day tomorrow. You guys have the remainder of the class period to quietly work on other things.